1 minute. All right, so we have 6 trig ratios. Until this year, you've had 3 trig ratios. The trig ratios you had were SOHCAHTOA. And then last year, when we put them about the unit circle, we just labeled the adjacents all x, the opposites all y's, and the radius for the hypotenuse, because that's what it is. Okay. There's ways you can remember these. So we have sine, cos, and tan with the y's and x's. In the past, people have come up with different words and acronyms to remember them, so I will give you those. They are wonderful. Don't hate them. Okay. So sine, you need to have the theta beside the word sine. If not, it is literally the word sin. Sin or tan or cot. If you don't have a theta beside it, it's just a word that just sits there. Cotan, C-O-T. So if you don't have the theta beside it, it's not actually an angle. It's not a trig ratio at all. So you need to have the theta beside it. Now, the way that people have come up with acronyms are sign your resume. So Y over R. They get better. This is one that really only makes sense. Cos theta, so to be sign your resume. This one is cook. Ooh, equal sign. It's X and R, so I'm not sure where old trout would help, but okay. Cook extra rice. Ramen would be good too. And then, like what the? Tan your Xbox. Makes no sense. You will memorize it. You will use it for life. Yeah. Who wouldn't want to tan your Xbox? I would, obviously. Perfectly fine. Just nope, my husband has a PlayStation, and we have a Wii from many moons and moons ago. No. Okay, so then we have the reciprocal trig ratios that are besties with those. Remember? So we have cosecant, and on the formula sheet it says 1 over sine. So cosecant and sine are besties, correct? Cosecant is just the reciprocal to sine. So if you remember sine your resume, cook extra rice, tan your Xbox, the reciprocal trig ratios of those are just the flip. So you don't need to have acronyms for those ones as well. You just need to take the original acronyms and flip them. So, resume your, yes. So, no. Sure. But we're doing it for cosecant. So cosecant, instead of it being x over r, sorry, cosecant's a sine. Instead of it being y over r, it's going to be r over y. Secant goes with cos. So instead of being x over r, it's going to be r over x. And cotan goes with tan. So instead of y over x, it's going to be x over y. So you don't really need to memorize those ones, right? As long as you have the top 3 memorized, the bottom 3 happen really easily. And if you forget which one goes with which, remember the formula sheet tells you. Cosecant 1 over sine, secant 1 over cos, cotan 1 over tan. It's actually on there. Okay? Then last year we also learned about cast. The cast rule, C starts here, we go C-A-S-T. Cast always told us where stuff was positive. So in quadrant 1, all 3 were positive, correct? How many trig ratios do we have now? 6. All 6 are positive. In quadrant 2, sine is positive, and what's its bestie? Cosecant. So cosecant is also positive there. That makes sense, because if sine was like -1/2, cosecant would be -2, right? It's still going to be negative. The sign doesn't change. The fraction flips, but the sign doesn't change. If tan is positive here in quadrant 3, what's its bestie? Cotan. And then cos is positive here. What else is positive? Secant. So we're just adding 3 more trig ratios, but it doesn't make life any more difficult. There's just 3 more to remember. But they're just a flip of the first 3, so it's not a big deal. All right. So for this one, they want us to give them the rotational angle, but we're not going to do that for today. But it wants us to list the 6 trig ratios. And I'm giving you a point. The point is -2, 6. So the first thing we're going to always do is plot it. -2, -6. So here's my point, and my terminal arm always comes from the x-axis from 0, 0, correct? And we always draw our triangle towards the x-axis, just like our reference angles. We never ever draw our triangles towards the y. So here's the triangle in here. What kind of triangle do I have? A right angle triangle. I know that this side length is -2. I know that this side length is -6. How do you suppose I could get the third side length? The hypotenuse by using what? Pythagorean theorem. So we're going to go r squared equals x squared plus y squared in this case, instead of c squared equals a squared plus b squared, because the c squared is actually the radius, right? If I drew a circle around here, the whole way around, that would be my radius. So we're going to find that. Radius squared equals -2 squared plus 6 squared, -6, sorry, squared. R squared equals 4 plus 36. R squared equals 40. When you take the square root, you always take the positive or negative. But what did I tell you about a radius? Radius is a length. So what does it have to be? Positive. So my x can be negative, my y can be negative, my radius always has to be positive. So when we take the plus or minus of it, that's fine, but the radius is going to turn to be positive. We also need to reduce 40. What perfect squares could I break 40 into? Perfect squares are like 4, 9, 4 and 10. Some people say 8 and 5. Those are 2 really nice numbers. However, neither of them are perfect squares. So you're not getting any better. You just now have square root 8 times 5 underneath it. It just looks ridiculous. Okay, we need it to be perfect squares. Why do they need to be perfect squares? Because if we take that perfect square and we square root it out, what does it become? 2. But if I have an 8 or a 5, can I take a nice square root of 8 or 5? No, it's a decimal of some sort. You're not going to do that. Okay, so it has to be perfect squares. So 2 root 10. And you did this in grade 10. You repeated it in grade 11. This is your 3rd year with it. So we need to be able to do these, just like decomp. If you still can't do decomp, which some of you I know can't, based on your polynomial test, and the factor question, and you still didn't factor it properly, there's a few of you, and by a few of you I mean way more than a handful, between my 2 classes, which scares me. I've never had that many. You need to come figure it out, okay? Which is okay. First step is acceptance, okay? So we have 2 root 10, and that's our radius. I'm not joking. If you still can't do decomp, please come in and figure out how to do decomp. You need it for the whole year. We're going to do trig factoring. If you can't factor normal decomp, when I throw a sign in there, it's going to get real awful, real fast. Okay? You need to know how to do decomp. If you can't reduce a radical, you need to come in and ask. I will never be like, oh, that sucks. I will be like, oh, that sucks when I mark your test and you can't reduce a radical. But I won't be if you come in. I'll be like, here, let's do like 800. And then you'll walk away and you'll be like, I know how to reduce radicals. This is the best day of my life. That's what you will do. I'm still recording. Awesome. Okay. Swell. X equals -2, y equals -6, r equals 2 root 10. At this point, I can now do every trig ratio, all 6 of them. Because what's involved in all 6? An x, a y, or an r, correct? And what do I have now? X, y, r. I can answer any of them now, right? Okay, let's do sine first. Sine. Right now it's sin. What do I have to put beside it so it's sine? Theta. Sign your resume. Sign your resume is going to be -6 over 2 root 10, which is fantastic, although we always have to rationalize our denominator. We started doing that last year. How do we get rid of a root 10? Multiply by root 10. And when you do something to the bottom, you have to do it to the top. So we now get negative 6 root 10. And then 2 times, what's root 10 times root 10? Root 10 times root 10? 10. What's root 10 times root 10? Root 100. And what's the square root of 100? 10. Oh my. Yeah. I'm going to. So you could, but all you're going to do if you multiply by 2 root 10 and 2 root 10 is you're going to end up crossing it back off. So you're just making yourself more work. However, if you do it, it's still going to get you the same answer. In the end, you just are going to cancel it back off. But you can. Okay, so 2 times, let's try this again. Root 10 times root 10 is 10. And 2 times 10 is? Oh, yeah, I was actually afraid for that one. You can take a 2 out of each of these. Now, the square root of 10, can I just go into the square root of 10 and cross something off? No. The only way you can take something out of underneath a square root sign is if you can take it out as a perfect square, like we did, right? We had a 4. We took the 4 out, it became a 2, correct? You can't just go under there and be like, oh, there's a matching one. I will just cross it off 10 and take a 10 out of everything. You can't. The only way something comes out of a square root sign is if it's a perfect square and you can take it out. Okay? Root 10 has no more perfect squares in it. It's not going to get any prettier the whole time. It's going to stay root 10. But I can take a 2 out of these two. So this can be negative 3, and this is going to be 10. So it's negative 3 root 10 over 10. So that would be the answer to sine theta. Cos theta. Cook extra rice. So what are we going to have this time? Yeah, negative 2 over 2 root 10. So I have to rationalize it. So I'm going to multiply by root 10 and root 10. So I'm going to get negative 2 root 10 over 20 again. Take a 2 out, and I'm left with a 10, negative 1. So I'm going to get negative root 10 over 10. Those are the two hardest ones, because they're the only two trig ratios that actually have r in the denominator, correct? And our r is the only one that actually has a radical. So we're not going to have to rationalize any more of them, which is nice. Okay, tan theta. Tan your x box. So negative 6 over negative 2, which is positive 3. Then we do cosecant. Cosecant is besties with what? Sine. And it's sine your resume. So cosecant is going to be resume your, or r over y. So 2 root 10 over negative 6. What could I do? Take the 2 out. This can become a 1. This can become a negative 3. So we're going to get root 10 over negative 3. Could I write that as negative root 10 over 3? Could I move the negative to the numerator? Yes. You can move the negative around. You just can only have one of them. So you can write it as negative root 10 over positive 3. You can write the negative completely in front and write root 10 over 3. And you can write the negative on the bottom. You can move that negative around, but you can only have one of them in the whole fraction. Okay, secant is besties with cos. Cook extra rice. So this is going to be r over x instead. So 2 root 10 over negative 2. So you get root 10 over negative 1. Are they going to write it like that? They're just going to call it negative root 10. And then cotan theta, the opposite of tan. Tan your x box. So this is going to be x over y. So negative 2 over negative 6, which is a third. Now, which trig ratios in here are positive in the end? Which trig ratios are positive? Tan and cotan. Which quadrant is it in? 3. What's positive in quadrant 3 using cast rule? Tan and, so you know you're right. You try number 2. Number 2 is way nicer because there are no radicals. Try it out. Okay, so this one, you're going to have positive 3, negative 4. It's always towards the x-axis. So we know that our radius, if we do Pythagorean theorem, we get 5. The other thing, too, is we know that the trig ratios that are going to be positive are cos and secant. All the rest are going to be negative because we're in the positive C spot, right? So cos and secant will be positive. All the rest will be negative. If that is not the way that yours are, something is wrong, okay? So sine your geez, now you have me doing it. Sine your resume is negative 4 over 5. And then cosecant theta would be negative 5 over 4. Or if you have 5 over negative 4, same thing. Okay? Cos is cook extra rice. So it's going to be 3 over 5. Secant is going to be 5 over 3. And then tan, your x box, negative 4 over 3. And cotan theta is negative 3 over 4 or negative 3 over 4 or 3 over negative 4. Those are all the exact same answer. You type them into your calculator, you'd get negative 0.75. So they all give you the same answer. Okay? Now, negative 12 and 5 over 13. If we do Pythagorean theorem to get our r, we know we have a negative x and a positive y, so we know we're over here. We know it's negative 12 over 13 for x, and we know it's 5 over 13 for y. We do Pythagorean theorem to get r. So it's going to be r squared equals 5 over 13 squared plus negative 12 over 13 squared. R squared equals 25 over 169 plus 144 over 169, which is 169 over 169, which is 1. The square root is plus or minus, but because it's a radius, it's positive. Now it says, is this point on the terminal arm, it should say, of the angle that intersects the unit circle? Is that point on the terminal arm? Yes. Why? Yes. So we're just going to do a couple trig ratios for this one. If we do sine theta, sine your resume, yours 5 over 13, resume is 1. So when I go 5 over 13 divided by 1, like that, if you have fractions, what I would hazard you to do is write them sideways. But anything over 1 is just itself. So this would be 5 over 13. We agree? But what happens if I go cosecant theta? It's going to be 1 divided by 5 over 13. If I have fractions, I always write them side by side. Because when you divide by a fraction, what do you actually do in order to do the operation? Yeah, multiply by the reciprocal. So you're going to get 1 times 13 over 5. So your answer is 13 over 5. What if I did tan? Tan your x bar. So it's 5 over 13 divided by negative 12 over 13. Is that helpful? Having a fraction over a fraction? Not only is it not helpful, it freaks people out. They don't know what to do with it. So write it out sideways. 5 over 13 divided by negative 12 over 13, which is 5 over 13 times 13 over negative 12. The 13's cancel, and I'm left with negative 5 over 12. So that's if you're given a point, okay? If you're given a point, you're always going to find R. So last year you were given some points, and you were given trig ratios and asked to find other trig ratios. That's what we're going to do as well here, except we're adding 3 new trig ratios to it. We're adding cosecant, secant, and cotan, okay? So here it says, given trig ratios and the quadrant of a particular rotation angle, find all the other trig ratios. We're not going to find all the other ones. We're going to find 2 for each, and I will pick them. But tan is what? Tan what? Your x box. If ever I ask you for trig ratios, you need y, x, and r. At the very minimal, you need 2 of the 3, depending on what trig ratio I'm asking you for, correct? So if I give you anything and I ask for a trig ratio, you need to get me somehow y, x, or r, right? So here they gave me x and y. Is that any different than what we were just doing? What did I give you in the previous page? X and y. And this tells you it's in quadrant 1. Why does it have to tell me it's in quadrant 1? Because they're both positive, and tan is actually positive in 2 quadrants, 1 and 3. Correct? Let's pretend it's not in 1. Let's pretend it's in 3, and I'm going to show you why. So this one's in 3 now. So if it's in 3, it's here. Okay? Now people will say, okay, y is 4, x is 5. Or they'll say, I don't need to draw it, Lepp. I know r is positive. Why do I care about drawing it? Why do you need to draw it? Y is not 4 and x is not 5. What are they actually? Negative 4 and negative 5. Well, why can they get away with not putting negatives on both of them? Because they cancel. So if you don't draw it, they often put tans in the 3rd quadrant because then you have to draw it and make sure that you know that those are negatives. Because a negative divided by a negative is actually positive, so the negative signs don't stay. Okay? Our R is still positive just like it was before. I don't know why I didn't draw the diagram in the diagram spot. You can do that. All right. Solving for the 3rd side, so we need R. R squared equals negative 5 squared plus negative 4 squared. R squared equals 25 plus 16. R squared equals 41. Square root. We take square root, you take the positive or negative. But because it's R, it's positive. 41 is a prime number. It's not reducing. Its only factors are 1 and 41. So I want you to do the trig ratio sine theta and secant theta. Go. So sign your resume. Yours for resume is root 41. It's negative 4, sorry. Multiply by root 41. So you get. So, like I said, if you don't draw the diagram, you're probably not going to know that it's a negative 4. What answer are they going to have on their diploma? Positive, because it's positive, right? Secant is the opposite of cos, so it's r over x. So it's root 41 over negative 5, or negative root 41 over 5. What answer are they going to also have there? 41 over 5, root 41 over 5. Okay? This one gives us the quadrant as well. What quadrant is it in? I'm going to just draw this one in the actual spot. In 2, and you always draw towards the x-axis. It's where sine is positive, correct? Sine is positive in 1 and 2, so they had to specify for us. Because this is a sine positive one, right? So sine is y over r. So they gave us 3 and root 10. So this time we're actually having to solve for x. And because I drew the diagram, I instantly know my x is what? Negative. Because to be here, the x has to be negative, right? So I'm going to write the negative sign. So I'm going to get x squared equals y squared minus r squared minus y squared. So x squared equals root 10 squared minus 3 squared. X squared equals 10 minus 9. X squared equals 1. X equals plus or minus root 1. But in this case, it's negative 1 because of where it's drawn. That's why drawing it is so important. So if I say secant, secant is the opposite of cos. Cos is x over r, so secant would be r over x. Cos would be a not so much nice one. Why? What's on the bottom of a cos? Rice. Rice on the bottom of the cos. And rice is square root, so you'd have to rationalize. Okay, let's look at 3 and 4. These are a little bit different. So instead of directly telling you what quadrant it is, it gives you information so that you can tell what quadrant it is. So tan is greater than 0 means tan is what? Tan is positive. So tan is positive where? This one and this one. So have they narrowed it down to 1 for me? No. What else do you have to look at so you can narrow it down? Your sign is what? Your sign is negative, is what someone just say you. Nice. Your sign is negative because sign is negative. Which one of those arms is where sign is negative? The bottom one. So this one's out, this one's in. So we know it's this one. So with the 2, we can make it into one quadrant. Sign your resume. Now what if they had it like this? Which they do often. What's the problem? Your R is negative. Can R be negative? No. So we'd make R be positive and move our negative to the top. Okay? So we have negative 2 and we have 3. Find your third side, and then I want you to give me cos theta and cotan. And then this one, I want you to get it, and then I want you to give me cotan and sine. And go.